Hello, welcome to IMS 2026 in Boston. My name is Krishna. I'm a product manager here at Anritsu. This year at IMS, we have released our latest VNA platform, which we are calling it as Tensor. Tensor is the best spec VNA till date from Anritsu with many advanced features, including an inbuilt AI assistant. For this demo, I'm going to briefly talk about our latest solution for high-speed cable testing. What you are seeing here is the DUT here is a 8 differential lane backplane cable. I'm using 2 breakout boards, one at the input and one at the output to split the 8 differential lanes into 16 single-ended lanes at input and 16 single-ended connections at the output. So a total of 32 single-ended coax connections are connected to this switch matrix. So in a traditional VNA testing, if I do not have any switch matrix, I'm using only a 4-port VNA. I'll use 2 ports of the VNA to connect to 2 ports of this breakout board and at the input, and 2 ports of the VNA to the 2 ports at the output of the breakout board. Now I have to do it 8 times because these are 8 differential lanes, and to characterize each lane. And on top of that, if I'm testing for crosstalk, I have to do a lot of permutations by disconnecting from one port to other port. Now with this method, there are a few disadvantages. The first is the time. Just to test a single cable, it will take hours to fully characterize all 8 differential lanes. Second is the reliability. As I keep disconnecting the cables and connecting it back, the connectors will wear out very quickly, and probably over time they will result in inconsistent results. The third is scalability. If mainly in production environments where we have to test a lot of these cables in one day, using just a VNA is not, it doesn't work anymore. So our solution to this problem is we have come up with a full integrated solution which consists of 3 components. One is the VNA. What you are seeing is a Tensor 26.5 GHz VNA. It comes in 2 variants, 26.5 and 43.5 GHz. Second is the switch matrix. What you are seeing here is a 64 port, which is 4 1/16 config switch matrix, but we can customize to a different version as well. We have 2/32. Now this is 4 1/16. So we have different combination, different variants of the switch matrix. And the third is the Anritsu test software, which is the critical part of this system. The test software is fully developed by Anritsu, and what makes this solution so powerful is that the entire testing, starting from calibration to the final giving the test result in a PDF format, everything is automated. And our software does full switching for each of the 8 lanes. It fully collects all the S parameters, including differential, insertion loss, return loss, crosstalk, skew, and it will save all the results in PDF format, CSV, as well as take screen captures of the S parameters. Now I'm going to show a quick demo. What I configured here is I configured 8 channels. Each channel is corresponding to 1 differential lane, and I'm only measuring the differential insertion loss. Now I click a start of the button. It started the switching. It's going through channel by channel. It's taking the measurements. And that's it. And now I see the past result here, but on the back end, it's collecting all the plots, saving in a PDF format. It saves a lot of time. It's also all the 3 problems I was talking about. One is time, it saves time. Second is reliability. The switch matrix has over 1 million switching. We guarantee over 1 million switching times. And third is a scalability. We can test a lot of cables in a single day with this approach. That's all for this video. Thanks for watching.